Okay, now let's have a look at the first example. A particle moves in a straight line. Its displacement, given the function of displacement, is given by s equals to 25t minus 5t squared. Okay, the first question. Find the displacement of the particle at t equals to 2 seconds. So, the answer for question A. Given function s equals to 25t minus 5t squared, and we know that this is the function of displacement. Okay. So the first question wants us to find the value of s when t equals to 2 seconds. So at t equals to 2, s is equals to 25 times by 2 minus 5 times 2 squared, which is just equals to 50 minus 5 times 4, which is 50 minus 20, which is equals to 30 meter to the right of O, obviously. So since the value of s is positive, then the object is 30 meter to the right of O. Now let's have a look at question B. When will the particle be at 70 meter to the left of O? Okay. Question number would be 1. Okay. If you look at question number B1, means that this question asks us to find t, since we when will. So we want to find t when s equals to left of O, means that negative 70 meter. Okay. So basically question number B1 wants us to find the value of t when s is equals to negative 70 meter. Why negative 70? Because the key word here, 70 meter to the left of O. Okay. So we just need to solve this. Given that the function s is equals to, let me see, 25t minus 5t squared. So if s is equals to negative 70, then negative 70 is equals to 25t minus 5t squared. Here we need to do the factorization, so bring everything to the left hand side. We will get 5t squared minus 25t minus 70 equals to 0. And we can simplify this equation, so everything divided by 5, so becomes t squared minus 5t, okay, minus with 14. So now we can factorize. So t minus something, t plus something, so minus 7 plus 2 equals to 0. We have t equals to 7, or t equals to negative 2. So obviously time cannot be negative, so t equals to 7. The answer is when s equals to 70, negative 70 meter, t is equals to 7. Now we move to the next question, which is B2. Find the displacement s of the particle at, when will the particle passes through point O again? Okay, question number B2 means that you want to find t when s equals to 0, because passes through point O again, which means that if we have point O and the object, say the car, it travels and passes through point O again, at point O s is equals to 0, because the object sits on point O, so the displacement is 0. So basically number 2 passes through point O again. The keyword here, find t when s equals to 0. Point O again. Okay, so we have the equation s equals to 25t minus 5t squared. So 0 equals to 25t minus 5t squared. 5t squared minus 25t equals to 0. And we can divide everything with 5. So t squared minus 5t equals to 0. Factorize t. So t minus 5 equals to 0. T equals to 0 or t equals to 5. So the answer is t equals to 5. At t equals to 5, the object passes through point O again. We are going to look at the next example. Here, particle moves in a straight line. Its displacement from a fixed point O at the time t seconds given by this function here. So that is a function of displacement. First, find the total distance traveled by the particle in the first 6 seconds. So how much the particle traveled in the first 6 seconds. Now we are dealing with total distance traveled. Okay, so to answer this question, normally we will have, I will show to you today 2 methods. The first one is motion diagram method. The second one is displacement time graph method. So we are going to start with the motion diagram method. Okay, I would prefer this method more than the displacement time graph method. Right. When we're dealing with total distance traveled, always check whether there's any turning points. How to check if there's any turning point? By letting v equals to 0. Why? Because let's say you throw an object upwards. It stops first. V has to be equals to 0. So it stops. Then only it turns around and falls down. So stops when we want to change direction. So again, for total distance traveled, always check for turning point. That is when v is equals to 0. Okay. Since we have s equals to 4t minus t squared plus 12, to find v, we need to differentiate s with respect to t, and we want to find turning points. Check for turning points. My handwriting. Check for turning points That is when v equals to 0. So this whole thing equals to v0 equals ds over dt. Differentiate that function, we should get 4 minus 2t. Therefore, 2t is equals to 4, t equals to 2. So turning points happens when t is equals to 2. So when we check our turning point, so now we do the table, okay? Because we want to draw the motion diagram method, we need to do the table. So how do we differentiate the table? What value do we need to use? It depends on our turning point and our endpoint actually. So we do the table T and S. T is 0, that's very important. And then when T is equals to 2, when it turns, and then when T equals to 6, because we want to find the total distance traveled within the 6 seconds. So when T equals to 0, insert that value into the S function, we will get 12. And 2 we will get 16, and 6 we will get 2. Right, we will get 0. Now we draw our motion. This is our fixed point. At t equals to 0, the object will be 12 meters from O. Okay. At t equals to 2, the object will move, and at t equals to 2, the object will be 16 meters from O. Okay. Because S is displacement, you have to know that S is displacement means that the shortest distance of the object from the reference point. Okay. And then we know that at t equals to 2, the object turns and it moves until it reaches s equals to 0 at t equals to 6. Hence, the total distance traveled is the value of that and plus that. So we know from 12 meter to 16 meter we have 4 meter. And from 16 meter to 0 we have another 16 meter. So the object moves 4 meter from the first 0 second to 2 second. And then from the second until 6 second, it moves another 16 meter. So which means that total distance traveled, how much the particle moves, is just equals to 4 meter plus with 16 meter, which is equals to 20 meter. And we know that distance, you don't have negative 20 meter because distance is a scalar unit, it's not a vector unit. So it doesn't really matter if the object lies on the right hand side or left hand side of the reference point O. The only important thing that we need to know is how much the object or particles moves. Okay, so distance is always positive. Okay, now we are going to have a look at the second method, which is the displacement time graph method. So which means that you need to draw a displacement against time graph. Okay. So to draw the graph, you need information. So since we want to find in the first 6 seconds, so we can start with T and S. 0, 1, 2, 3, 4, 5, 6. and we have 12. Insert that into this equation here. We have 12, 15, and then 16, 15, 12, 7, 0. Now we draw the graph. So S against T, 1, 2, 3, 4, 5, 6. Here I'm going to use scale of 2, 4, 6, 8, 10, 12, 14, 16. Okay. So when T equals to 0, S is equals to 12. When T equals to 1, S is equals to 15. Equals to 16. I should put something like that. 16. Oh, my. 16, and then 3, 15, and then 4, 12, and 5, 7, like that, and 6 at 0. So if you look at the graph, it's going to look something like that. So basically the object travels up for 4 meters, and it turns and it goes down. Okay, it travels up 4 meters, and it goes down another 16 meters. Not say up or down. It goes to the right hand side, and then it change direction and go the opposite direction for another 16 meters. So total distance traveled just equals to 4 meters plus 16 meters, just equals to 20 meters. So you can use any method that you prefer. Okay, now let us have a look at the second question, B. So find the distance traveled by the particle during the 7 seconds. So this question is different from what we have in A. For A, we have the question total distance traveled in the first 6 seconds. But for B, the distance traveled during the 7 seconds. What does it mean by during the 7 seconds? Okay. I'll go to the basic definition. When we say during the first second, which we will refer from T0 until T1. During the seconds, refer to T1 until T2. During the third seconds, refers to from T2 until T3, which means that during the 7 seconds means from T6 until T7. So back to our question B. The distance traveled by the particle during the 7 seconds. We know that when given our S is equals to 4t minus t squared plus 12. Okay, when t equals to 0, when t equals to 6, S equals to 0. So now we find for when t equals to 7, S is equals to 4 times 7 times with 7 squared plus with 12, we will get negative 9 meter, which means that if you look at the motion, this is your fixed point. At t equals to 6, the object will be on top of the fixed point, and it moves to at t equals to 7, the object will be 9 meter to the left of the fixed point. So it means that the object, the distance traveled, it travels for 9 meter. So the answer for this question is equals to 9 meter. Why do we do not consider the negative sign? Because negative sign just indicates that the object is on the left side of O, but in terms of distance, the object moves 9 meter. Now we are going to move to our next question. A particle moves in a straight line. Its displacement s meter from a fixed point O at its time t seconds is given by this function. Okay. Find A, initial velocity of the particle. Okay, go back to our notes. When we're dealing with initial displacement, initial velocity, initial acceleration, always let t equals to 0. Not other things, but t must equals to 0. So back to our question. Okay. Initial velocity. Right. So we have s equals to 9t plus t squared. They ask us for initial velocity, which means that we need to find v. So v is just ds over dt. It's just equals to 9 plus 2t. So initial velocity happens when t equals to 0. So v equals to 9 plus 2 times 0 equals to 9 meter per second. So that is the answer for your question A. Now we go to question B. The velocity of the particle when it is at 52 meter to the right of O. Okay, right of O. So find, if you look at question B, it's just find B when S is equals to 52. Why positive? Because it's right of O. So now we have S equals to 9t plus t squared when S equals to 52. So 9t plus t squared equals to, everything I move it to the right hand side, you should get t squared plus 9t minus 52. Then you have to do the factorization. T. Let's try maybe 4. So 13 times 4, positive, negative. So now we have t minus 4 equals to 0, t equals to 4, or t plus 13 equals to 0, or t equals to negative 13. There's no negative time, so the answer is t equals to 4. So v is just equals to, from here, 9 plus 2 times 4, which is 9 plus 8 equals to 17 meter per second. So when the object is 52 meter to the right of O, the velocity of the object is 17 meter per second. Okay, now let's look at the next question. A particle is moving in a straight line. Its displacement as meter from a fixed point O at a time t seconds given by that. Find the displacement of the particle when it's instantaneously at rest, means that the object suddenly stops. Instantaneously at rest, is the value of t equals to 0? No. Is s equals to 0? No. So the object can move and suddenly stop. So what's confirmed 0 here is the velocity. So in other words, find s when v equals to 0. That is for our question A. Now we have the function s, t to the power of 3 minus 6t squared. And we know v is just equals to ds over dt. So we want v equals to 0. So 0 is equals to differentiate that. We should get 3t squared minus 12t equals to 0. Then factorize 3t, t minus 4. Let me see. Okay. So we have two conclusions here. 3t equals to 0, t equals to 0. T minus 4 equals to 0, t equals to 4. So instantaneously at rest means that the object starts at rest from t0. The next one, it's instantaneously at rest, is when t equals to 4. So just substitute the value of 4 into the displacement equation. So we have 4 to the power of 3 minus 6 times 4 to the power of 2. We should get negative 32 meter. Okay. So which means that the object will be 32 meter on the left side of O. Now for B. The range of values of t when the particle moves to the right. Moves to the right means that if you look at our notes, moving towards right, v is greater than 0. So we need to find the range of t. Find range of t when moves to the right, v is greater than 0. So we know that v is just equals to that. So v equals to 3t squared minus 12t. We differentiate the displacement function, we should get v. And then greater than 0 means that 3t squared is minus 12t is greater than 0. We did the factorization just now. It's greater than 0. Then we have, what kind of graph is this? Now we want to solve inequalities. So it's solving inequality by graphing method. Positive value of coefficient of t squared. So we have small graph there. And then critical value. We already find the critical value just now. Okay. Critical value should be at t equals to 0 and t equals to 4. Greater than means that the top part. So t should be less than 0, then t should be greater than 4. But since t is time, we do not have negative time. So we only consider t is greater than 4. Which means that particles move to right when t is greater than 4. Okay, for the next question, a particle starts moving in a straight line from fixed point O. Its velocity, now we are dealing with the function of velocity. It's given by v equals to 20 minus 40, where t is the time in seconds after passing through O. Find the maximum displacement of the particle. So displacement is s, and we know that s is obviously a function of t. So for any graph, if you want to have maximum, say maximum area, we are going to have dA over dx, maximum volume, dV over dx. In this case, we have a function of s and f, s and t. So it means that maximum displacement is just when ds over dt is equals to 0. Okay, why? Say you have a graph of s against t, and obviously at maximum point, the gradient, which is just the ds over dt, must equals to 0. Gradient must equals to 0. That's why at maximum point, we let ds over dt equals to 0. Okay, gradient equals to 0. The thing is, do we have the function s? No, we do not have, but we have v. Given that v is equals to 20 minus 40, and to find s, we need to integrate v with respect to t. Back to our notes, remember? If we are given v, to find s, we must integrate v. Okay? So if we are given s, to find v, we differentiate s. But if we are given v, to find s, we need to integrate v with respect to t. Okay? So which means that we need to integrate the function 20 minus 40 respect to t. We should get 20t minus 4t to the power of 2 over 2 plus with c. Okay, so this is just s, so s equals to 20t minus 4 divided by 2 to t squared plus c. Now we need to find 4 plus c. Look at the information given in the question. A particle starts moving in a straight line from a fixed point O. Okay, so we can say that, unless stated, we can say that from this equation, we can say that at t equals to 0, s equals to 0. So therefore, that at t equals to 0, s equals to 0. This is obvious from this statement, from this statement, the first line. Okay, so we can conclude that st equals to 0, s equals to 0. So insert the information into the s function. So 0 equals to 20 times 0 minus 2 times 0 squared plus c. Obviously, we can see that c is just equals to 0. Therefore, s is just equals to 20t minus 2t squared plus 0, which is as 0. So now we have the function s. But we're not done yet. We want to find, oh my god. Okay, we want to find maximum displacement. So we let the s over dt equals to 0. It's very simple. Actually, they've given us that v is just equals to 20. Oh, I'm sorry. I'm so sorry. ds over dt is just equals to v, which is just at maximum. It's just equals to 0. So we can use directly v. 20 minus 40. We do not have to do this step. Sorry. 20 minus 40 is just equals to 0. 40 is equals to, oh, we still do need to use that step. Sorry. Okay. 20 minus 40 is equals to 0. So we have 40 equals to 20. T equals to 20 divided 4. T equals to 5. It's very important for us to find these because eventually we need to insert the value of t into the displacement function. If we have c, who knows? If we don't try, we don't know whether we have c or not. But in this case, our c is equals to 0, so it's coincidence. Okay. So now we have the function of displacement that we find through the process of integration from v. So now insert the value of t into the equation. So maximum displacement is just equals to s equals to 20 times 5 minus 2 times 5 squared. We should get 50 meter. That is our maximum displacement. Okay, now let's have a look at this question. The particle starts moving in a straight line from a fixed point O. Its velocity v is given by this function here. Okay, where t is the time in seconds after passing through O. Find the distance traveled. So distance traveled by the particle during the 4th second. So the term during the 4th second means that we need to find how much the particle travels. The distance, how far, not how much, how far. So how far the particle traveled from during the 4th second. So from t equals to 3 until t equals to 4. Right. And normally for distance travel, I will check for the turning point. So we want to check for the turning point. Okay. When v equals to 0, so you should get 0 equals to 12 minus 60. 60 equals to 12. T is equals to 2. So turning points happens when t equals to 2. So when we have t equals to 3 and t equals to 4, the object will not turn. It turned before when t equals to 2. So from t3 to t4 is just a straight line. So we just need to find the value of s when t equals to 3 and the value of s when t equals to 4. But before that, we were given v. to 12 minus 16. So if we want to find s, we need to integrate v with respect to t. So we just do the normal integration. So it becomes 12t minus 6t squared over 2 plus with c. So you should get 12t minus 3t squared plus c. And let's have a look if there's any indicator about the initial s when t equals to 0. So it in this question, it doesn't state anything about t equals to 0. So we can assume that at t equals to 0, s equals to 0, therefore 0 equals to 12, 0 minus 3, 0 squared plus c. So we can imply that c is just equals to 0, therefore s just equals to 12 t minus 3 t squared. Okay. Now we find when t equals to 3, s is just equals to let's see. So when t equals to 4, s equals to 12 times 4 minus 3 times 4 squared. So which means that if you look at the diagram, so say this is your fixed point. At t equals to 3, the object will be 9 meter from O. This is t equals to 3. This is t equals to 4. The object will be on O, so it moves for about 9 meter from T3 to T4. So the answer, distance covered, is just equals to 9 meter. You don't have to put negative or positive because it's distance. Distance, you do not have negative or positives. Distance is always positive. Okay, alternatively, I want to show you one more method to answer this question. Okay. By using integration as well. Right. So we have already checked that our turning point is at T2. So it's out of the range of between 3 and 4, which means that if we want to find distance traveled, so we need to find s, it's just integration from 3 to the 4th second of v with respect to t. Okay, so which means that if we integrate, we should get 12t minus 3t squared, or 3. You should get 0 minus 9 should get, I mean, top minus bottom, no more integration, so we get 12 times 4 minus 3 times 4 squared minus with 12 times 3 minus 3 times 3 squared. You should get a negative 9. Negative 9 is just the negative shows that the object is possibly moving towards the left hand side. But well, there is no negative for distance. What you can do, you just modulus that from the start. Okay, so the final answer is just 9. No. We will say the total distance traveled just equals to 9 meter. Okay. If you ask me personally, I think I will use the second method in this case. Easier. Okay. Let's have a look at this question here. A particle moves in a straight line. Its velocity v after passing through a fixed point O is given by this function. Okay. Sketch a graph of velocity against time for time from 0 until 4. So they want you to draw graph of velocity against time, and obviously if you want to draw, we will need to produce a table. So T and V. So T starts from 0 until 4. So 0, 1, 2, 3, and 4. Insert those the value of T, into this equation. The corresponding value of V will be negative 3, negative 6, negative 5, 0, and 9. Now, since we already have the table, now we can sketch the graph or draw. Draw means that you need to use good scale, real scale. Okay, say the maximum value of V is 10. So now I've done the scale. We plot the points, and when forget 10, 8, 6, 4, 2, 0, negative 2, negative 4, negative 6. So 1, 2, 3, 4 seconds. When t equals to 0, v is equals to negative 3. When t equals to 1, v is equals to negative 6. When t equals to 2, v is equals to negative 5. And when v equals to 0, when t is equals to 3, v is equals to 0, there's a turning point here. Okay, so v equals to 0, so t equals to 3. This is the turn, the moment when the particle turns. Okay, then when t is equals to 4, v is equals to 9. So the graph should look like that. Okay, so we've done this question A. Now we want to do question B. Hence, calculate the total distance traveled in the first 4 seconds. The first 4 seconds. Since the turning point is at 3, so which means that if you want to find total distance traveled, so which is just distance. We need to integrate the function of v with respect to t from 0 until 3, then add with from 3 until 4. And the values, probably we are going to get positive or negative since the area of the curve is below the t-axis. So I'm expecting that the first value should be negative, but you just need to model this both and remember to separate according to the turning points. And obviously integration of v, you get s, which is displacement. So we need to find s since we want to find the distance traveled. Okay, so it's just equals to integration from modulus, integration from 0 until 3 of the function. So the function is quite long. So we have to be very, very careful in dealing with the function. So 3 into 4 of 2t squared minus 5t minus 3 with respect to t, again modulus. So we integrate as usual, so you should get 2t to the power of 3 over 3 minus 5t to the power of 2 over 2 minus 3t. And remember the boundaries, 3, 0, plus with, again, the same function, except that the boundaries might be different. Okay, so the boundaries is from 3 until 4, so becomes modulus 2 over 3 times with 3 to the power of 3 minus with 5 times 3 to the power of 2 over 2 minus with 3 times 3, and then you will minus this whole thing, top sector. If we insert the value of 0 into each term, we will get 0, so it's just minus 0 modulus plus with, again, 2 to the 4 to the 3 over 3 minus 5 4 squared over 2 minus 3 times 4 minus the top minus bottom. Should get the value here should be similar to this value here. Okay. Should get modulus. If you press your calculator, you should get negative 13.5. Okay. Plus with modulus of minus 9 1 minus 9.5 minus with minus 13.5. Okay, so we modulus that, we get 13.5 plus with, that should be 4 1 over 6. So press your calculator, you should get 17 2 over 3 meter. Okay, that is your answer. Okay, for our next question, a particle moves in a straight line and it passes through a fixed point O. Its velocity v is given by, so we have a velocity function here. t is time seconds after passing through point O. Find acceleration A of the particle when its velocity is 8 meters per second. Okay. Answer A. If V equals to 8, then we have 8 equals to t squared minus 3t minus 10. So 0 equals to t squared minus 3t minus 18. So t minus 6t plus 3. So we have two answers is equals to t equals to 6 or t is equals to negative 3. Do not consider this one because we can never have negative time. So if v is equals to 8, then t is equals to 6. But the question wants the acceleration. So we know that a is equals to dv over dt from our notes before. If you want to find a from v, you need to differentiate the function v. Okay. So we differentiate that function. So which is just equals to differentiate the function. We should get that function here. So it becomes 2t minus 3. Okay. If t is equals to 6, then a is equals to 2 times 6 minus 3, which is 12 minus 3, to 9 meter s to the power of negative squared. Alright, so the object or the particle is actually accelerating. Okay, B. Find the acceleration when the particle when it reverses its direction. So when it change the direction when v equals to 0. So this is a turning point. That is when v equals to 0. First we need to find the moment where the object turns by letting v equals to 0. So 0 is equals to let v equals to 0. So t squared minus 3t minus 10 equals to 0. T minus something, t plus something, factorization minus 5 plus 2, so t equals to 5 or t equals to negative 2. Obviously t is not equals to negative 2, we consider t equals to 5. Therefore a is just equals to 2 from here times 5 minus 3, which just equals to 10 minus 3, which is equals to 7 meter per second. Okay, so that's the answer. Right, for the next question, I'm not going to show this question. I'm just going to discuss on how to deal with this question. Okay, the acceleration is given. So it's given A. Given that velocity when the particle passes through O is 6, means that t equals to 0. The initial, I think it's the initial velocity. T is equals to 0, v is equals to 6. So find the maximum velocity. Maximum velocity is just dv over dt is equals to 0. So with all the given information, I think you can answer this question. Let me see. So the final answer for this question is maximum velocity is equals to 22 meter per second. You can try on your own. Okay, that's the end of our video. But before we stop our lesson for today, I would want to go back to the key points in this chapter. Okay, first, if you are given a displacement function, to find velocity function, you need to differentiate the displacement function. To find A, you need to find dv over dt. And if the process reverse, to find v from A, we need to integrate A. To find s from v, we need to integrate v. Okay, that's the first lesson. The second thing we need to know is that when we talk about initial displacement or initial velocity or initial acceleration, you must let t equals to 0. And when it's mentioned, if the object is on the left of O, the value of s should be less than 0. If the object or particles is on the right of the fixed point O, then s should be greater than 0, such that O is the fixed point. The third one, at any turning point, or if the object is instantaneously at rest, or probably maximum or minimum, to talk about distance, maximum or minimum value, depends. It depends on the condition. I think if it's object change direction, it turns instantaneously at rest, then we must have the value of v equals to 0. And also remember, total distance traveled must always check for the turning points, which is when v equals to 0. And there are a few methods that can be used to find total distance traveled. Maximum velocity, obviously dv over dt equals to 0. Moving towards right, the value of v greater than 0. Moving towards left, value of v is less than 0. So velocity increase, a is greater than 0. Velocity decrease, a is less than 0. So a greater than 0 means the object is accelerating or accelerate. A less than 0 we call as decelerate. Okay. That's all for today. I hope you understand today's lesson. I'll see you soon. Bye bye.